that I think I haven't shown you is what's used instead of the empirical rule, and that is the interquartile range. And I'm going to show you that today, and it's real simple. I mean, it's only 2 formulas and really 3 formulas, but if you're not going to use the empirical rule, and I'll show you in just a second, I'm going to get to the e-text, and I think it's in 3.5. I'm not sure. .5 if it ever comes up. Okay, that's nice. My session has ended. I haven't even, whatever. That did that to me yesterday, and then I clicked it again, and then it went into it. So I don't understand. There we go. And we're going to go to chapter 3. I think it's 3.4. I think. Yeah. So let me find the page, let you write it down. Yeah, here it is. Okay, go ahead and there's the interquartile range. Write that down. I just want you to write down the formula because I'm going to explain everything in just a second. So the interquartile range is a number that we use in another formula. And it is the 3rd quartile minus the 1st quartile. And that's the first thing you need to remember. And then the second thing is the other 2, which sets your boundaries for your outliers. There they are. The lower limit is Q1. I call it the lower limit. Q1 minus 1.5 times the interquartile range. The upper limit is equal to Q3, the 3rd quartile, plus 1.5 interquartile range. Now, those are the 3. That's what you're supposed to use if you don't use the empirical rule. Okay, what do you mean, Hubert? Well, let's say that I'm trying to think of, well, I'll tell you what's the best thing to do. We'll do the interquartile range. That's all you need to know. I'm gonna get out of that and go to homework questions. Had a couple of homework questions sent in from the 120-29 class yesterday, and I kept them because they were decent test questions, and I wanted to show y'all the same questions. And I think somebody sent in one from this class. Let's see. There's 120-24. Okay, this is 3.235/11. And let's see what that one says. Okay, we've already went over that, I think. Did we go over Chesnev inequality? I think we did. Somebody meant did we go over Chesnev's inequality? We'd never use it, but did we go over it?
Yeah.
I thought we did. Yeah, just do the best you can with that because that's not a test question. Okay. 3.2, this is 120-24. 3.2, number 9. Let's see what this one is. Trying to find one. Okay, that's that one with 50. Did we do that one?
Yes.
Okay, good. Because that one, that one's awful. All right, let's try to find one that's a little bit easier on the, let's see, 3.4, 14/7. Okay, this one, I haven't seen this one, so I know we haven't done this one. A manufacturer of bolts has a quality control policy that requires it to destroy any bolts that are more than 4 standard deviations. Okay, write that down, highlight that. 4 standard deviations from the mean. The quality control engineer knows that the bolts coming off the assembly line have a length of 14, mean, and a standard deviation. When you see, and I might have told you this, I might have told the 12029 this, whenever you see mean and standard deviation, that means draw the damn curve. Okay? Usually when they give you mean and standard deviation, that means draw the curve. So let's draw the curve. I'm going to pull up my handy dandy do-jigger. And I'm going to turn down the resolution. There we go. Okay, so I'm going to draw the curve. Now, I ain't worried about the, I don't know why that cord wants to, there. Okay, so draw the curve. This is not the question I was wanting to show you, but it'll do for right now. I got to add another standard deviation because the question says 4 standard deviations. Okay, so let's go back to the mean. Move this over a little bit, make it smaller. 14 and 0.10. So the mean is 14, and that's going to be 14.10, 14.20, 14.30, and 14.40. And then over here, it's going to be 13.9, 13.8, 13.7, and 13.6. Now with 4 standard deviations, it's going to be hard to, unless they want you to change it to a z-score, and we might have to do that. So let's see. It says in the question, select the correct choice, blah, blah, blah. Do they want you to do a z-score on this one or not? Let me see if they're wanting a z-score. Yep, z-score. You're going to have to do the z-score. So it says, for what lengths will the bolt be destroyed? The bolt will be destroyed if it's what? If it's more than standard deviations from the mean. So that means, go back to our picture. That means I'm going to take my red marker, and you know I don't use red. That means if it's out here, or out here. Because this is 0, 1, 2, 3, 4. And this is -1, -2, -3, -4. So we've got to calculate a z-score for this point, and we got to calculate a z-score for that point. Now, since it is symmetrical, it will be the same number, the same z-score, but one's going to be positive and one's going to be negative. So here we go. Z-score is equal to x minus x bar over standard deviation. X minus x bar over standard deviation, which is going to be z is equal to 13.6 minus 14 over 0.1. And let's take our handy dandy and the other one while you get your calculator out. Z is equal to X minus X bar over S. And Z is equal to 14.4 minus 14 over 0.10. And I can do this one in my head. 0.4 divided by 0.10 is equal to 4. There's 4 dimes and 40 cents. So that's 4 and that's 4. And of course, it does come out to be the same thing. Sometimes it doesn't. Okay, so you always need, and sometimes they're not going to give you exactly 13.6. Sometimes it may be 13.25 or 13.85 or something like that. And you have to figure the, so in this case, anything beyond -4 and +4 is going to be destroyed. So let's go back to the question. So that's going to be 13.6. Let's see, less than 13.6 and greater than 14.4. That should be your answer. That's a good test question. So make sure you know how to do that one. Remember, when it says mean and standard deviation, that's a key word for draw the curve. All right, I'm going to delete that one. I'm going to delete the other two also. Let's see what this one, I think we probably went over this one, but I'll ask. Let's see, 349/5. 1 year TED, lowest ERA, okay, of any pitcher at a school with an ERA of 3.35. Also, Susan had the lowest ERA of any female pitcher of the school with an ERA of 2.93. For the males, the mean was, okay, you got to calculate z-scores for these guys. Now, better is not more extreme. Better means closer to 0. All right. Now, when we did our LBJ the other day, remember, LBJ, hold on a second. LBJ versus Shaq, that was who was better or who was taller. That's who was taller. Taller is when you say something like taller, wider, or anything like that, that's the further out from the z-score is closer to the what? The outlier. So the more further out you are, that means, you know, the relatively taller would be LBJ because he was further out. When you're talking about better, like a better score, like a better test score or better grade, the closer you are to 0 is best. Okay? So that's probably why you're a little bit confused on this one. This one says we got 2. Ted had the lowest ERA of, let's see, 3.35. Ted, 3.35. And Susan had 2.93. Okay, the mean for the guys. So the mean for the guys, X bar is equal to 5.015 with a standard deviation of 0.632. For the women, for the women, 5.089 with a mean or a standard deviation of 0.844. So figure the z-score for both. All right, so this is going to be 3.35 minus 5.015 divided by 0.632. And this is going to be 2.93 minus 5.089 divided by 0.844. Now these are negatives also. Negatives make a difference. Okay. So let's see, let's pull up our handy dandy calculator. I'm going to have to pull it up. Hold on a second. There's our handy dandy calculator. And we'll go ahead and pull this up. There we go. So clear 3.35 minus 5.015 divided by 0.632. I get negative 2.63. And the other one, 2.93 minus 5.089 equals divided by 0.844 is negative 0.256. So let's take the first one. Negative, let's say he's Ted, so he'll be blue. Negative 2.63. Negative 2.63 is going to be down here. So there's Ted. Negative 2.55 is going to be right here. And that's Susie. So, which is better? Well, you could look at it this way. When you're dealing with negatives, what's better to have in the bank account? $500? I mean, negative $500 or negative $300? Which is better to have in the bank account? Somebody needs to say something.
Negative 300.
Negative 300 is better. So in this case, you could say, okay, it's better because negative 2.56 is higher than negative 2.63. We're not asking for the most outlandish. We're not asking for the, who's taller or wider, who's got the better score. Okay? The better score is who's closer to 0, which should be, what's her name? Susan. So the answer should be Susan. Let's check and see if I can get back to it. It says better. Ted had a better. Okay. It's still okay. I'm sorry. It's still the one that's outside. I'm sorry. Okay, Ted had the better. It's okay. I got it mixed up. I'm sorry. So it's not better score. It's still closer to the outlier. Here's the outlier. So there it is. I got mixed up there. Sorry. So you have to go with the outside. What's closer to the outside? What's closer to the outlier? Remember, the outlier is the measure of the z-score. So whoever's closer is whoever's closest to the outlier is the one that has the better one. Why does it say lower? He don't have, okay, lower because negative is lower. That's why. I think that's why you might have got mixed up with that word right there. Even I got mixed up with it. It's the lower z-score because it's negative. Okay. So my bad on that one. Next. Okay, that's that one. I want to get to one where I can do some numbers so I can do the interquartile range. Okay, this is 3.4. Have we already done this one? Let's see. Okay, this is one. This is like the previous question, finding the z-score. We did this one with the bolts. Suppose babies born after gestation period of 32 to 35 weeks have a mean of 2,500 and a standard deviation of 800. Okay, so they're telling you to draw a curve there. While babies born after gestation period of 40 weeks have a mean weight of 2,700 and a standard deviation of 375. If a 34-week gestation period baby weighs 2125 and a 41-week gestation period baby is 2325, find the corresponding z-scores. Okay, why is this problem confusing? Because it has too many numbers in it. That's why. You got this 32 to 35, and then this weight, and this mean, and then you got 40 to 40. That's why it's confusing. So what you need to do is, first of all, draw the 32 to 35 curve. So I'm going to have to make this small. Okay, it just disappeared. Some Russians. Make it small. Thank you. Appreciate it. Okay, so the first thing you do is 32 to 35, and you write down that information. Okay, they have a mean, so X bar is equal to 2,500, and S is equal to 800, and your X is equal to, let's see, where's the first one? If a 34-week gestation period baby is 2125. Okay, so there's your information for the 32. Now, what's the other one? Born after, so 40 week, after 40 week. Okay, let's write down its mean of 2,700, mean of 2,700, and a standard deviation of 375. You know, they don't want you to draw this. They just want you to do the z-scores. And on a 41 week, that is 2325. All right, I need some of y'all with calculators to do this, okay? So what's the minus 300 mean? Or is that another question? I see minus 300, but I don't know what that means. Okay, so 2125 minus 2,500 over 800. Somebody calculate that for me and give me 2 decimal points. And somebody calculate this one. 2325 minus 2,700 over 375. Okay, somebody get the first one for me. Give me 2 decimal points.
Negative 0.47.
And somebody give me this one over here.
-1.
Is it -1 even?
Mm-hmm.
Okay. All right, so the one that's further away is -1. So let's see, what you got right here. -1 is smaller than 0.47, -0.47. So you got to pick the one that says that. So baby and 34 relatively less, relative should be B. I think that's probably, let's see. Oh, they just answered the wrong answer. It is B, but the answer, that's not, you got to change it to a Z-score. Okay, so that's that answer. So we got the right answers. They just put the wrong answers in. Okay. Both of these are test questions, so make sure you can change Z-scores or change into a Z-score. (3.4) 21/12. I'm trying to hurry so I can get to a numbers question, do the interquartile range. Okay, the accompanying data represents miles per gallon of random sample with 3-cylinder, 1-point-liter. Compute the Z-score. Okay, what do they got for us? Okay, they got this. Okay, determine the quartiles. Here we go. We got a good problem here. So first of all, I'm gonna send it to Excel. You can punch it in your calculator. Go ahead and punch them in your calculator if you want to. Let's see, how can I do this? Let me just do it on the Excel spreadsheet and go ahead and put it in order, and then you can punch them in order. So I'm going to punch these in order for you. So I'm going to highlight. They may already be in order, but I'm going to check it. Here they are. Okay, so I'm going to make them a little bit bigger so you can see them. And that's as far as I'm going to get. There we go. So go ahead and type those in your calculator, or if you have a spreadsheet, go ahead and type them in your spreadsheet. Give you a minute to do that. And we're going to do everything here because I want to show you the quartile range and all that stuff. We're going to do mean, median, mode, range, standard deviation, all that stuff. Probably take the rest of the class. And while y'all are doing that, I'm going to go over here and put mean, median, mode, and all that good stuff. Mean, median, mode. And I'm not going to look for mode on this one. Y'all can look for it, but it's good. The more decimals you have, the less of a mode you're going to have. Range, mid-range, variance, and standard deviation. And I'm also going to put 5-number summary down here. Mean, first quartile, second quartile, third quartile, and max. I'm going to go down here and I'm going to do interquartile range. Oops, sorry. Interquartile range. And lower limit and upper limit. Do so much for y'all. Y'all ought to feel blessed. Okay. So let's find the mean, and that's going to be the summation of all these divided by 24. Median, well, we got 24, So that's 12 and 12. So we got to go 11 and 11. So go down to 11, and these are your two numbers. So that's equal parentheses this number plus this number divided by 2. And that's also our second quartile. And while we're at it, the min is right there, and the max is right there. Okay, mode, I'm not going to worry about it. If you see a mode, go ahead and tell me so I can put it in here. If not, I'm going to move on. Y'all don't need help to observe something. Y'all need help calculating, so that's what I'm doing. Okay, range is that. The mid-range is equal to the lowest plus the highest, or the highest plus the lowest. It doesn't matter. Divided by 2. And the variance, I'm going to go ahead and equals this number minus the mean. And I'm going to copy that down. And I'm going to square it. And most of y'all should know how to do that. We've done 3 or 4 problems, I think. And summation. And that is your numerator for your variance. So equals this divided by 23, which is 24 minus 1. And then this is going to be the variance raised to the 0.5 or the 1/2 power, or take the square root of it. Now remember, that's green, that's green, and that's green, because those are important. And they're fairly close to each other. You know, these are decimals, so it's going to be more detailed. The decimals, you got a 39 here, you got a 39 here, and a 40 to 41 here. So with decimals, that's pretty close. So you know you got somewhat of a normal curve as far as the way the numbers go. Standard deviation is also important. So we'll color that with a more fluorescent. Let's go with that color. Okay. Now, remember our blue dot. Remember me saying the blue dot? Okay, let me pull up my handy dandy, and it was on here, but it's not now. Hold on a second. What am I looking for? I'm looking for that. There we go. Now, do you remember me telling you that the mean represents, or not the mean, but the median, I'm sorry. The median represents the middle of these two numbers. You remember me telling you that? So put your blue dot right there. That's the middle. Actually, it's right here. There. All right. And how many numbers are above that blue dot? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is even. So that means we're going to go 5 down. 1, 2, 3, 4, 5. And we're going to take the mean of those two. And I'm going to highlight those, maybe a bluish color. And that's going to be that number right there. So equals, parentheses, this number plus this number divided by 2. Now do the same thing on the bottom. 1, 2, 3, 4, 5. So these two are going to be, and we'll color that with some kind of a orange or something. And that's equal to parentheses, this number plus this number divided by 2. So now you've got what you need for your interquartile range. So they'll go down here, and I'm going to bring up my handy dandy dojigger here. Remember our formulas for the interquartile range. The interquartile range is Q3. Q3. I don't know what's wrong with my voice this morning. Sorry. So Q3 minus Q1. So that's going to be equal to Q3 minus Q1. Okay. And now go back to our formula. Q1 minus 1.5 of interquartile range times interquartile range. So this guy is going to be Q1 equals Q1 minus parentheses 1.5 times interquartile range, close parentheses. And this is going to be Q3 equals Q3 plus parentheses 1.5 times interquartile range, close parentheses. Okay, now I'm going to show you what all this means. Well, first of all, let's do the curve. So I'm going to put the mean right here. And I'm going to add my standard deviations equals this plus the standard deviation F4. I'm going to add two more on this, 3 standard deviations on the right, and equals this number minus the standard deviation F4. Enter. Copy that, 2 more to the left. So I'm going to highlight that. I'm going to make it centered and bold. I'm going to color this, that green that I use. Okay, and now you can draw, I'm going to try to, y'all better not laugh at me. And put a little dot there, a little bigger dot there, a little bigger dot there. I'm trying to draw this. Don't laugh at me. Draw that there. And if you laugh at me, then I'll have to go out and do things to my pickup truck to overcompensate for things like that. All right, so now I'll take my handy dandy, move this down to here, and we've got a curve that looks like that. Now what this says is, and I want you to understand why I'm saying this. Why won't it go away? Go away. All right, we know that 95% of the numbers are going to fall between these two numbers. Okay, that's what that means. We're using the empirical rule. And we know that 2.5% or 2.35 is going to be unusual. And then we know that after 49.5 and below 28.4 is outliers. Now that's why I'm showing you this, because if you don't want to use the empirical rule, then you can use the interquartile range to tell you where the outliers are. So in this case, we don't have any outliers because 48 is within the blue area, and 32 is within the green area right here. So you don't have any outliers according to the empirical rule. But what about the others? Well, that's what I'm fixing to show you. Okay, so let's do our 5-number summary, our box plot. So I'm going to draw another number line. And I'm going to put a little end there and a little end here. And that there. And I'm just going to cheat a little bit. I'm going to put my mid-range here. Mid-range goes there. And of course, I got to do better. I got to center it. Well, that's close enough for government work. This is the min. This is the max. And we got to graduate. So I'm going to say the middle right here. It's going to be right here. Let's see, 32 to 40 is 8. Half of 8 is 4. So that's going to be 36. And 4 here would be 44. And then half of this would be 46. I'm trying to do it the best way I can here, and that'd be 38. Okay, now I take my blue marker and put it at 37. 37 is right in here. That's not going to work. That's so cute. Hold on. Let me go to the line. Put a blue line at 37. And what are my other lines? Let's see. That yellow line at 39. 39 be right in here. And then our orange line at 41. 41 would be right in here. So it looks like we got a normal curve because the yellow is close to the 40. So it looks like we got pretty much a normal curve right here. There's your box plot. Don't judge. Okay, there's your box plot. And now let's look at the interquartile range. So the interquartile range, and I'll put it up here.
You have a work email.
Their number for the outliers is 47.025. And their lower number is 30.8. That's the difference. And I'll put these two in red. Okay, the reason I'm putting them in red is because they're the interquartile range, and they're a little bit different. If you don't use the empirical rule, you'll use the interquartile range to tell you what the outliers are. Hopefully you understand that. Give me a hand raise if you understand what I'm talking about with the outliers versus the empirical rule. Just hit the hand. Okay, I got one person, 2 people, 3 people. Okay, we got some people understanding it. Okay, that's good. Good. All right, so that's it. And let me tell you, if you can do this, and you can do the 2 or 3 questions we did about the z-scores, then you're good to go for the test. Which means I think we're probably ready for a test Friday. meaning that I'm going to go over the test Friday. I've already got it made out. I just finished making it out before class. I think it's got 35 questions. Now remember, 13 of those questions are bonus questions that you better not miss. If you do miss them, then you don't tell anybody. The rest of them are chapter 3 questions with a little bit of chapter 1 and chapter 2. That means I will set the homework and the test up dates wise Friday before we go over the test or after. Okay. So this covers pretty much everything in chapter 3 except for the z-scores. You got your empirical rule, you've got your box plot, you've got your 5-number summary, you got your interquartile range, and you've got your lowercase statistics right here. So there's not much anything that I haven't done in chapter 3 except for the z-scores on this one problem. Anybody got a question on what I've done on this problem? Breakfast of Champions. I'm not telling you what's in here. Any questions? Okay, so let's see what the question asked in the first place. And it says compute the z-scores corresponding to the individual. Okay, 39.4. So if we're going to calculate that 39.4, then let's calculate it. So I didn't do that. So they want to know the z-score with 39.4. So let's go back to the Excel spreadsheet, and I'll go down here. Z sub 39.4 is equal to, and I'll make that a little bit, well, I can't. Well, I'll just do this. I'm going to try there. Okay, and make this a little bit wider. So that's going to equal parentheses 39.4 minus what? Well, we got to minus the mean and divide that by the standard deviation. So the z-score is 0.13, which would be right in here. 0.13. Let's color this. Sounds like a song. Let's color this purple. Okay, it sounds like a song. Dang old Prince. Let's color it some kind of purple color. Lavender, lavender. And take our, I bet I don't have a lavender pen. Let's see what kind of colors I got. Well, I don't have lavender, so I'll use that magenta. I don't know why they, wait a minute, here we go. We cooking with peanut oil now. Let's see. Let's go with that color. Oh, well, it's close. So that 0.13 is going to be right about there. So it means it's a little bit better than half. I don't know what they're going to ask about it, but there it is. There's the z-score. All right, let's get out of this and see what else they're going to ask. Determine the quartiles. We did that. Compute and determine the interquartile range. We did that. Determine the lower and upper fences, lower limit and upper limit. Are there any outliers? So I think there is an outlier by the interquartile range. So let's look. The interquartile range says 30.8. No, we don't have an outlier on this end because all these numbers are above 30. 47.03, we have one outlier. So I'm gonna highlight this one. I'm gonna put that in italics because that means that number is an outlier because it's above our interquartile range, but it's not above our empirical rule. So depending on which one you're looking at, that's an outlier. We'll change. Let's change that to. Let's change the. I don't know. Somebody give me a color. Let's change it to blue writing. There. So that 48.8 in blue right there, that's an outlier by the interquartile range. So does everybody understand? Everybody good? I'm not going to type in all those answers. I'm sorry. You can look at this sheet and write down the answers and do that. I'm not going to do all that. Okay? All right. So with that, let us convene. Let me check the roll right quick because y'all was not here Monday. And let's go ahead and establish who was here. Look forward to a test, a review test, Friday, which means that you'll probably have the weekend to do the test and probably a few days next week to do the test. You'll have 5 days. Okay. So, or 7 days. I can't remember what I give you. But anyway, home, attendance tracker for 1/20/24. Let me go ahead and shut down this and shut down the recording.